Yes. So today, I think I set it up, but Dan is probably a dead giveaway here. But today we are talking about space mining, which I am super excited about. But before we dig into that, let's go ahead and go around and introduce. And then Dan, I'm going to have you go last. You can dig a little bit more into who you are and what your background is. So we'll go Tatiana, Emily, Alessandra, and roundtable like that.
Okay. Well, thank you. Hello, everyone. I'm Tatiana, and I'm head of data science here at Prospector. And my background is basically all technology work, development, data science, and machine learning, and all data engineering.
Awesome. And hi, everybody. I'm Emily King. I'm one of the founders and CEO of Prospector and a geologist, a terrestrial geologist by background. Yeah. Alessandra?
Hi, my name is Alessandra. I'm happy to be here. I'm happy to be learning with all of you about asteroid mining or space mining because that's something that I don't manage that much. Well, my background is in finance, project evaluation, and I have a degree in mineral energy economics from Colorado School of Mines. That's how I heard about space mining that much.
Very, very cool. I'm Daniel Sachs. I'm the founder and CEO of the Canadian Space Mining Corporation. My background is in not in space or mining. I guess it is now, but it was previously in real estate, private equity investment, development finance, and a little bit of venture capital investing.
Awesome. Great. So quick question. So how did you go from real estate venture capitalist to where you're at now?
Yeah, I think thankful to the help of the pandemic, I had some existential crisis, which made me realize that my whole career working in real estate, finance and investment had been worthless to humanity.
Where you're at.
Right. And so I wanted to work on something that could move the needle for civilization. And that led me to space and to space mining. There was this return to the moon that was going on called the Artemis missions. And alongside that, it would require a substantial amount of resources on the moon, produced on the moon. And so that's kind of where it began. Along with that, I realized there was a document in the Canadian government called the Mining and Metals Plan, which is Canada's mining strategy document. And they had identified space mining being of strategic national importance, and no one was really doing anything about it. So that was a couple of years ago, and started quite earnestly, and then built from there. And at one point, I guess I had unintentionally started a space company.
Crazy how that happens. Yeah, so that's super interesting because we've been seeing, as you mentioned, a lot of news, especially in the last couple months, about space mining and asteroid mining, and it seems like it's going from science fiction to reality. And we talk a lot here at Prospector about deep sea mining, partially because I'm just so fascinated by it. But we're moving our mining futures discussion today to the outer reaches of space, the final frontier. So really quickly, in 2 sentences, I would like you all to go around and same pattern here and summarize your initial thoughts on space or asteroid mining. Those of you watching, feel free to drop your thoughts in the comment section as well. Just initial thoughts, pings, ideas, 2 sentences. Keep it real short, challenging here.
And start again. Okay, well, 2 sentences a little bit difficult, but to me, it is super important because we cannot always rely just on the resources from Earth, especially as we do explore more and more of the space around us. It's just too expensive to drag everything to the orbit if we need something right there. So definitely the future. And a benefit is just exciting. So it's all exciting to explore other planets. So even if it was useless, I would still do it.
That's That's a great motto for a new space company, Tatiana. Even if it's useless, I would still do it.
It's a passion.
For me, I think the two sentences would be, well, the two things I think about immediately are construction and propulsion. So, like, how do we mine things in space to build in space and to be able to further explore space? Like, how do we mine the fuels that we'll need essentially for propulsion to get even farther out? And then my other thought is like gravity. Like, how do you do separation? How do you process the rocks that you mine without a lot of the techniques that we use here on Earth, not just the actual extraction, but the processing and refining process, I think is going to look totally, totally different in space than what we see here on Earth. Again, also not two sentences. Sorry, Jess. Alessandra?
All right, I'll go. I think that my first thought was, as a financial person, if it is expensive, is it worth it? It is unpredictable, and most of it, how am I going to value space mining with so many uncertainties to value? How are we going to manage demand? What are the revenues of the stream? Are we going to use it just in space? Are we going to bring them back to Earth? So I'm just thinking about cost, and if with the current technology or the technology that is in development, if we are going to make it worth it to extract mineral from the space.
All very good questions. I have two thoughts that come to mind, and one is making space more sustainable. So making our activities in space more sustainable, and that means a lot of things. It means an ability to refuel rockets in space, to reduce the upmass that we bring to space and stay places. And then from that, the ability to solve real problems on Earth with the technologies that we're creating to fill these gaps, and to disrupt the way we're currently doing the resource industry on Earth, which is archaic.
Awesome. All great thoughts and questions. Thank you all for that. I do just want to share, we had last week in our weekly nugget a poll on space mining. And so again, I kind of in my head relate space mining to deep sea mining, because they're just like these both way out there, like sci-fi seeming things that are now becoming a reality. And when we talk about deep sea mining, everybody's like, no, we can't do it. We don't know enough about the ocean and all that stuff. But then when we talk about space mining, on the other hand, most of our poll responders were like, heck yeah, let's mine space. Which I think is a really interesting, because in my head, like, do we know enough about space? Like, what about the aliens? You know what I mean? So I thought this was a really interesting poll response. We do have a lot of people that are all for it, or like maybe in the near future, like not quite there yet. So I just wanted to share those poll responses here real fast.
It's great to see such enthusiasm.
Yeah, I was very surprised, but it's very, very cool.
I think one of the primary, differences between space mining and deep sea mining, right, is like the ocean is one of our most important ecosystems, and there are, potential for long-term catastrophic effects from making the wrong decisions there. Whereas space mining, you're really shifting that activity outside of our ecosystem in a way that can really benefit people.
It's
the
like
ultimate NIMBYism.
That's what I was just going to say. Not even our backyard. Like, it's not even on our planet, so we really don't care.
Right.
Yeah.
Unless we find like a civilization of extreme NIMBY aliens, and then we got issues.
Yeah, or just like little itty bitty microscopic creatures that have the ability to kill us all. Like, if they're not happy we're there, like that could impact it too. Totally different social license to operate.
Right.
Yeah.
Are you talking about our DNA that came from space and created the whole life on Earth?
Exactly, Tatiana. We're getting back to our roots. Yeah.
Oh my goodness. So before I do have questions like that teed up here. But first I wanted to go kind of round table again. We'll go opposite this time. We'll start with you, Dan. But when I looked on Google or Answer the Public for questions that people have about space mining, aside from like the processing stuff, the first question is, why space? What's the reasons? What's even out there? How realistic is it? Is it possible? Is it profitable? And is it even legal? Because who owns space, right? So those are some of the big questions that I see from like just the general public on space mining, besides even the technical processing questions. So we're going to go opposite. Dan, I'm going to start with you to maybe answer some of ththose bigger questions, and then roundtable to kind of bring up more questions.
Those are a lot of questions. So why space? I mean, I think it's part of our character as humans to explore. Since we crawled out of the caves and crossed the oceans, it is we've been trying to answer the great questions of who we are, where we came from, what else is out there, and what it all means. And I think going to space and exploring space is fundamental to that. I don't know that we ever answer those questions, but we continue to unravel the mystery, only to find more mystery. It is quite viable. Why you would go to space and space mine is to create a sustainable supply chain in space in order to sustain activity in space for refueling, for life support. And then there are a lot of materials in space. Our Earth's resources are finite. There are an infinite amount of resources. You take the 16 Psyche mission, which has been getting a lot of news around it. And the amount of precious metals on that one asteroid dwarfs the precious metals content of our entire planet. So, or the available precious metals content of our entire planet. So I think if you look at some of these facets, it's going to be part of our long-term supply chain of how we build things within this civilization. If you're looking 50 or 100 years down the road, we have to be thinking about these things now in order to be there at that time. There's also stuff like helium-3, which is going to be crucial if we're able to transition to fusion reactors. We're going to need helium-3 that is likely not going to come from this planet. It's going to come likely from the surface of the moon in order to sustain that type of technology, quantum computers and stuff that also require sources of helium. So, we need to be thinking about these things now as we're building this technology for the future. The other thing is Earth's gravity is not going to change. And I think it was Emily, you were talking about, the need to build enabling technologies in space, the need to build and construct hardware, whether that's satellites, spaceships, and other technology in space from the raw materials there. And we burn almost all of the fuel just getting the up mass into space, into low Earth orbit. It's inefficient. And so at some point, Alessandra, there's a tipping point, right, between the economic value of producing stuff on Earth and bringing it up to space and the economic value of producing material in space once you've built enough of a scale in order to do that.
Awesome. Thanks for those insight, Dan. Alessandra, we're going to go opposite here. So you're next on any other questions or any thoughts or insights you might have on that, if any.
Yes, I think that what is going to be crucial is already important for mining technology, but I think that if we are talking about space, it's going to be more decisive. It will be the breaking point of deciding to invest in a project or not, because we will need initial capital expenditure are going to be much more expensive than the ones that we have right now in the mining projects on Earth. In terms of operational costs, I'm thinking about energy or other special costs that are related to those new technology that definitely are going to change how we value things. As I mentioned at the beginning, is the revenue stream. Are we going to be using it only in space? In those cases, definitely that will be very efficient to do it. It may be less expensive, but if we are thinking about once we run out of material, that are going to happen in a long time because we still need to go deep on the Earth. If we're going to be bringing from space, that would definitely raise costs. And something that Jess asked as well that I think is important is regulation. Who owns the space? How are we going to manage which companies or countries are able to mine in one asteroid of the other one? Who is going to own the because we only own the Earth, we do not own the space. So how are we going to manage that? And also, I think that supply and demand, that's something also important, and we are going to evaluate mining on space, because that's much more unpredictable. We depend on technology, and also how much time are we going to recover the investment if we are talking about something that is very in the earth and it's not much not as concrete as any other project that we may evaluate on earth. So those are my thoughts about space mining in the finance world.
Yeah, I think my immediate thought from that is, both from a legal and regulatory perspective and also an economic perspective, is how similar really the economy of space mining might be to basically the economy of cryptocurrencies, right? Where you do have a connection to the way that the current world mostly operates from a financial perspective, and like valuation and cost and everything. But there are also these other values that drive that expansion. Because to me, like when we start mining stuff in space to build habitable communities and to be able to move around space, like you're mining these things because you need them to survive, not necessarily because of their economic value, right? And therefore, who's paying those companies to do that? It's going to be largely, I would imagine, government driven or quasi government bodies that are set up to do this. So it's not purely like a normal capitalist economic incentive to go do this. It's for all these other reasons. And eventually there will be a space economy that is not reliant in any way on anything on Earth, right? Like this is where I'm like a complete sci-fi geek, like have been for the longest time. And my brain goes to the series The Expanse, right? Where you've got like Mars, the asteroid belters, and then the folks still on Earth. Like you'll end up with these multiple economies that basically trade amongst themselves, and have economic ties. But it's not like the way we think about the cost of material and the value of material here, right? So it's like stuff that we don't think of as very valuable currently may be incredibly valuable in that construct. But how do you finance it? Heck if I know. Yeah. Can't do it based off of a return, to your point, Alessandra, right? It's not really about a financial return at that point.
Yeah, so you know, government is plays a big role in this, right? And government is driving the return to the moon that's going on, and fundamentally, as an international community, they're working towards that goal. Part of that will require space resources to maintain that and to make that sustainable. So it's a goal driven by them. Our cost of bringing mass like water and other materials to orbit right now to the lunar surface is around $1 million a kilogram. And so it's backing out of that. If we have to bring every kilogram of water to the moon, that's quite expensive. And of course, those will reduce as our cost of lunar landers and stuff like that go down. But in order to sustain that, we really need to produce the materials there, which can then also be brought to low Earth orbit. So there's been some great studies done in that regards.
Yeah, to me, it's also, I think of space exploration in a similar way like Emily does. It is actually what we consider the future of human race, right? If we do want to carry on being alive, we need to do something about space, because our planet wouldn't be habitable for forever. Mars might be our next place where we can survive as human species. So we have to do that in any case. And the point of economic value right now, I think it is more of trying to find some low-hanging fruit where we can convince people easily that we need them right now. But in reality, it is similar to financing a war. People always find money to fight a war because they have a reason to convince their nation that it's necessary. So the monies are always there. There is no actually money. It's the work that people are prepared to do to survive. and people are prepared to do any work that they need to do to survive. So from that point of view, once we're getting closer to the potential of extinction of human race on Earth, it will be easier and easier to convince people that we do need to invest more and more in space. In fact, everyone will start investing mostly in space. And from the other point of view, the other interesting part is, how do we partition the space? Does it belong to us? Well, technically nothing belongs to us. So whatever we grab, it's ours until somebody contests it. And to some degree, it might sound a little bit unethical, but in reality, that's what life does. Life grabs whatever it needs for living, and we just try to compete. And then if we have extra resources, we try to let other life also live. So there is, again, no option for us. The interesting point, of course, is what is going to happen with the nations on Earth. And it would be great to have like one international society where all countries suddenly will become peaceful with each other and try to support each other. But knowing human nature, this is also not very probable. So we'll carry on as we do now.
Yeah, no, if I can jump in too on that, I think, Tatiana, to your point, like, and this is where, Jess, as you were mentioning, there are similarities with deep sea mining, where we do have the UN regulating deep sea mining, like approvals, right? And I know, Dan, you might know there are space bodies that, at least at a certain level, are governing like where potential, like on the moon at least, where people may be allowed to build up communities, right? Do you know anything? Because of course, legal and regulatory infrastructure is so key in the regular mining space and the terrestrial mining space. Like, who is in charge of that stuff?
So it's the UN as well, right? You have the Outer Space Treaty of 1967, which is the main governing document for space, the main treaty governing space. And then you have, liability then flows down from there to a nation state level. So as a US company or a Canadian company, you're regulated by your own government, and they're liable for your activities in space. The problem was, when the Outer Space Treaty in 1967 was created, we had a handful of spacefaring nations. We did not have commercial activities in space. We did not have commercial companies operating in space, nor did we have really a concept of the utilization of space resources. So the international community has been trying to move towards a framework for space resources. They have not done so yet. It is part of the work that needs to be done. And so there's the Artemis Accords, which were signed by the US, Canada, 8 countries total. It's now snowballed to about 25 countries, give or take, over the last couple of years. And it is a growing consensus for how to treat commercial use of extraterrestrial resources. But we're not there yet, right? Like, it's not at a UN treaty level. And obviously, quite noticeably absent from that are China and Russia. And so we need to get to an international consensus, and something that is at a UN level. Is it going to be, off what the Artemis Accords are based on? Maybe, plus or minus again. I don't know how far you're going to get from that if you already have, a lot of countries in consensus. And then on top of that, you've got 5 laws passed at a nation level at the US, UAE, Luxembourg, Japan, and most recently India, passing space mining laws at a domestic level.
Very cool. Thanks for that, Dan. That answers a lot of questions. While we're quickly on the subject of questions, I have one from Glenn here. Has there been any studies on what mining the moon would have what mining the moon, I guess, what effect mining the moon would have on our tides or our ecosystem here on Earth? what is the timeline to mining production in space, and how do I get involved? Or anybody?
Yeah. What's the timeline to mining in space? Let me address that first. Timeline to mining in space is, I guess, I'll ask you, how long do you think it would take to get a mine built on Earth? What are, you think, reasonable timelines from concept to operation?
So the latest study I saw was what, like 11.4 years or something on average?
Yeah. So according to the international community, we need materials produced on the moon, particularly 50 tons of water by 2030. So that's about 7 years from now. So those are the timelines. You have international missions being planned, other infrastructure being built that is interdependent on mining on the moon within the next 7 years. And look, there are delays happen all the time. You could lose a year or two from that timeline quite easily based on some piece of technology or another not being ready. But that's what we're shooting for. So I think within the next 10 years, we'll have mining on the lunar surface first for oxygen and water, and then following that for other materials like critical minerals and rare earths. And then asteroid mining, I think we're much further out. We're still trying to figure out exactly how asteroids are composed, what their surfaces are made of. We've made 3 trips to asteroids as a species that have recovered materials. So 2 by the Japanese and 1 most recently with OSIRIS-REx. That gives us more insight than we had into the surfaces of asteroids, but there's still some big gaps there. You're going, on the moon, you're in a microgravity environment, right? So you have 1/6 Earth's gravity. In a asteroid situation, you have on some of these almost no gravity, and then it's just a completely different type of environment to be operating in, which is going to require a larger gap in technology. So I think you're reasonably probably looking at the first small scale asteroid mining in the late mid to late 2030s.
Very cool. That seems so soon, which is crazy to me because it seems like this crazy sci-fi concept. And Emily, I know you touched on this a little bit before, but I know you are a huge sci-fi geek. What roles do you maybe see popular culture playing in space mining, especially on the side of public perspective? I know we've talked a little bit about this before, or on the technology side of things, Emily.
Yeah, I mean, I think in general, the kind of refocus on space is a huge opportunity for popular culture to refocus on the cool parts of science and technology in general, right? And how they all come together in what most people think of as a theoretical environment. So space mining in particular could get people really excited about geology. What is the geology of the moon, of asteroids, of Mars? What does that mean? What are these minerals that we need in order to, why, for folks that aren't already kind of sci-fi geeks, how do you mine water and air out of the moon? How does that work, right? I mean, that is a really cool, exciting science project, essentially, to re-engage the world's population in how science allows really cool, amazing things to happen. And I hope that also translates into excitement for innovation here on Earth. And what I think of as the Velcro effect, right? Velcro was invented by NASA, for spacesuits and other stuff, right? And now, can you imagine a world without Velcro? No, most people can't. At least people with kids like me. What would I do without Velcro sneakers? Life would be way more difficult. So I hope that's one part, and that it gets people really excited, almost like with the moon race. What's the show that's coming back on? We were just talking about it on our team. The one about what would have happened if Russia had won the space race. Yeah, For All Mankind. The next season's coming out. I think for me, I'm always amazed at the fact that we put people on the moon without what we think of today as computers or any of the cool gizmos that we have. I mean, that's amazing, right? Some people doubt it. Hello, all you conspiracy theorists out there attending our live stream. But I mean, that's amazing that we could put people on the moon without all the technology that we have. So what can we do now with all of this amazing technology that we've developed since besides just have Twitter/X, right? So I think that's what I think about is it should hopefully change Earth's relationship with science and technology to have this big push into space.
Awesome. Dan, what about your perspectives on kind of that pop
Yeah.
culture vibe?
I think that's fundamentally you really hit on it, Emily. That's the whole ethos of our company, right? Like if you ask what we do at the Canadian Space Mining Corporation, it's solving long-term problems in space that solve immediate problems on Earth. And so that's stuff like working on solving these problems around making oxygen and water on the moon, which can address some of our looming challenges on Earth related to water and clean air. It's about finding new ways to identify and prospect for resources on the moon that are more efficient, that can disrupt terrestrial industry here. It's about developing new ways to deliver healthcare on other planets that can address our immediate needs for healthcare here. And so it's all these things. Space technologies have constantly and continually driven innovation for big challenges on Earth in ways that we could predict and in other ways that we could not predict. A lot of the MRI processing technologies that are used today come from the original image processing from the Apollo missions. And so in ways that we were trying to process images for the moon actually yielded insights for how we process medical images. There's other ties between medical imaging and various telescope works and satellites that have been built. And so you're never really sure where the innovation comes. The beauty of going to the moon is we have all these huge challenges to solve, right? And so it's this infinite pool of hard problems, and solving those problems will drive innovation and novel science that can end up being applied in unknown and known ways.
And do we have, Dan, especially in Canada, because Canada is such a huge presence for the terrestrial mining community, like, are there mining companies or even like mining equipment companies that are involved in these discussions so far? I would hope so. I would hope like Caterpillar is building moon mining equipment, or at least involved in the conversations, right? To, again, capture some of that excitement and innovation. Are you seeing that?
Yeah, so Komatsu in Japan has been working with the Japanese Space Agency, JAXA, towards adapting some of their technology. I know Caterpillar has been working with NASA and the US government for a long time. I think, in Canada, there's certainly some movement towards that, and we're here to work with other companies that want to be part of this new supply chain. But, kind of like in the terrestrial mining industry, I don't think innovation comes from the majors. Innovation is driven and de-risking is driven by juniors and the explorers and the risk takers. Right. And so that's how we kind of see ourselves, right? That we don't think that it's not going to be a Barrick that's going to pave the way to mining on the moon, right? It's going to be the mavericks like myself who are willing to take the time and risk and opportunity to do so. That will open it up for everyone else. But we're here fundamentally. We think it takes a village, and we're here to work with partners across that value chain.
Very cool. Awesome. Very, very cool. So we are running out of time, just a smidge here. So I'm going to put a last call for comments and questions in the chat/comments section. And while we're waiting for people to kind of ask those final questions, what kind of like final thoughts do you guys have, especially like Tatiana, you from like the AI kind of side of things, Alessandra from like the data and finance side of things? We'll kind of go round table again and squeeze in any final thoughts or ideas here while we're waiting for people to ask questions. So Tatiana, I'm going to start with you.
Okay, well, from the AI point of view, here the AI is not doing anything groundbreaking. It just carries on doing what it was always doing, trying to help us to make easy decisions without our presence. So basically, the most important part is making autonomous robots and other equipment that can react to unknown situations outside the Earth area. So this is the most important, I think, for us, because we don't want to always send humans to various locations where it's not comfortable for humans to be. And delaying, because the communication as well is quite slow between the Earth and wherever we are going, like asteroids and Moon and Mars and so on. So it's very unproductive to always halt all work and then wait for communication from the Earth to resolve the problem. I think we can see it all the time with Mars rovers, where the things are slowed down, no one knows what's happening. With the probes that we have sent in 1970s, sometimes they disappear for 2 weeks, no one knows what's happening. So we want those gaps to be handled by AI more or less well, hopefully better than we can do in any case. So this is the most important part, but there are also more traditional data analysis tasks, such as analyzing where to go, what are we looking, how can we use very limited knowledge about what information that we collect about the geology of planets or asteroids structure, how we can use this information to guess the rest. So this is, I would call it traditional data science. And I honestly believe that human race is basically moving into a direction of becoming more like cyborgs, where we would give up a bit of our human biology because it is very inconvenient, and have our souls encompassed somewhere in a half human, half robot body. And here again, exploring space is very interesting to me because, RNA came from space. So this is a programming language of programming biological matter. And this is what we need to understand. And from what I hear, because all the things about life outside the Earth were kind of a taboo for many decades, there is very little investment right now. So people are investing in things that are more theoretical, and it's basically the investment into life outside the solar system, well, outside the Earth actually, in general, is very insufficient. And I think it is a great mission because we can learn so much about how life can be created, what are the mechanisms to change. Like we have genetic engineering already here on Earth, but we kind of do so little, and there is so much that we can do once we understand this programming language of biological computers, not I consider ourselves as biological computers. So this is AI part of space exploration.
Yeah, I mean, I think I agree with a lot of Tatiana's points that we haven't looked at it enough to really even understand the potential there. And a lot of it, I think, has been just up until, I would say, like the last 2 years. Like if you talked about this stuff, people look at you like you're a weirdo. And yet now we've got like all of these documentation and evidence of, what do they call them now? Like UFOs, basically, like in the US, right? Like these unexplained aerial phenomenon. I forget what they call it now, where it's like there was like no reaction to that just about in the news this year. That was like not even the top 10 weirdest thing that happened in the world this year. It was like basically the US military saying, yes, we can't figure out what these things are. So I think there's so much there that we haven't looked at. And I think again, I'm really excited about how excited people will get about the science. And like I know we've got at least one geophysicist on the chat right now. Like, I mean, basic stuff to me that will be really cool. Like, will geophysics techniques work in space? Like, you can't use, I assume, gravity magnetics data, right? Or certainly not in the same way. So like, it's one thing to just talk about like deposits at the surface, but how do you do exploration in space? Like, how do you do all of this stuff without disturbing dust that goes up and makes huge dust clouds and pollutes, the moon or Mars atmosphere? Like the technology of how you build a drill rig without having copious amounts of water, or like vibrocore drills, where again, I would assume that it would create a huge pollution cloud that you wouldn't want for other reasons. So I'm really fascinated by that. As part of what I love about science fiction novels and TV shows that really get into the mechanics of how people think this stuff will work, right? And kind of come up with these inventions in a fictional atmosphere, because like these are all really detailed questions that we'll have to figure out in order to make this stuff a reality. And a lot of it comes down to, science is important. we need people to be really excited about science and figuring it out. Really deep thought of the day from Emily. Science.
Those are all very good thoughts.
Very good. Just speaking of deep thought, Hitchhiker's Guide to the Galaxy, very relevant there.
Yep.
Sorry,
relevant.
I just pinged a tickled a nerve in my brain there.
Don't forget your
Yeah.
towel when you're
Towel. Yes. Yep. Alessandra, it's your turn there.
All right, so I think I have two perspectives when we talk about the space mining in general. First, if we are talking about in the nearest future, I think that if we are talking about mining to use on the space, I think that I am 100% of a supporter. I think that the investment, although it's going to be large, it's not going to be as expensive and as riskier as talking about exploring or doing mining in space to bring back to Earth. So from that perspective, I think that will take much more time because we will need investment from private companies. And for that, I'm going to move into the data, is that they need more data. And I think that at this point, we don't have enough data to make a financial investment decision that doesn't involve a high risk to pursue. And something that mentioned briefly, Emily, and I think it's important, is that if we remember the history of mining, we started with the unknown. We started going into trying to exploring new areas, discovering how to different minerals as we start discovering them. And all of that at the beginning, the mining was something that pollutes a lot because there were no regulations for all the pollutions. So I think for all the pollution, or we were not as concerned about environmental as we are right now, or as we started being aware about 25 or 30 years ago. So if we talk about space, I would prefer to go the reverse way that we did in Earth with mining. We need to first see how we are going to regulate what environmental potential issues we are going to find in the space, regulate those, and then we can start doing mining, because I don't want to happen in the space the same thing that happened on Earth, that we pollute for tons of years until we started regulating and learning more about how to reduce or even eliminate the risk of mining. So those are my thoughts. We need someone to regulate not only for who owns the space, for the rights, but also about how we are going to be working on space. I'm not going to talk about ESG because we're not sure about the S part, or if we're going to find some communities on space or something like that. But at least taking about what we know is the environment. We need to avoid disruption, the governments as well.
Awesome. Thanks for those. Dan, how about you? Final thoughts, comments you want to get out there, insights and ideas?
All very good comments and thoughts. I mean, I think there's lots of technical challenges and innovation that need to be solved, as Tatiana was saying, that can drive more robotics, more innovation, which is disruptive to terrestrial industry. There's tons of gaps to fill in terms of data and geophysical information, geotechnical information, which we believe and we have seen that can change the way things are done with terrestrial mining industry. We've already created entirely new geotechnical and geophysical technologies as a company in the work we're doing for space. And there are a lot of issues that need to be figured out, as Alessandra was saying, in what is the right way to go about this. The reality is we don't have the luxury of sitting around and waiting and trying to eliminate all the risk. I mean, I think, it's easy if you're in a terrestrial resource role to look at it and say, okay, well, we can, once we've eliminated all the risk, we don't have time for that. Right. So there are all these interrelated missions going to the moon that are going to need these resources in order to sustain them. And it starts small from there. And, likely we need to figure this out in multiple steps. In the immediate years, is it needed to figure out all the issues? No. Should we be ensuring up front that we are trying to export best practices as humanity and not our worst? Definitely. Right. Is it economically viable to mine on the moon? Sure. There's lots of studies that have sufficient data. We know there's enough water. We know there's a high amount of oxygen content within the regolith, and these things are quite valuable. As it pertains to resources from asteroids and other stuff, there's greater levels of uncertainty, and we'll get there when we need to get there. I'm optimistic. I think there's never been a more exciting time for space, for mining innovation that can be driven from space mining, and that can positively affect the way that we do mining on Earth, as well as drive innovation across a number of sectors.
I look forward to being able to carry space mining 43101s and jorks, just like we do deep sea mining ones, right, Jeff?
Yeah, we're gonna have to really redo it's gonna have to go from like Google Earth to like where they do the space thing a long time ago. Cool. We are like out of time, so thank you all for joining. Daniel, if people have questions or they want to follow what you're up to and whatnot, what is the best way to get a hold of you, ask questions and whatnot?
Yeah, we're on Twitter at Dan Sachs, at CSMC_SCMS on Twitter or X or whatever the hell it's called at this point in time. And we're on LinkedIn, which still functions normally. Canadian Space Mining Corporation, CSMC. Come follow us and reach out and find out. We're always looking for people, for investors, and for strategic partners. So don't be shy.
Awesome. Thank you. And as always, if you want to keep up with what's happening in the mining world, we here at Prospector, follow us on LinkedIn, Twitter, and everything else as well. And again, just keep an eye out for this recording in next week's Weekly Nugget. If you're not subscribed to the Weekly Nugget, head over to our website to do that now. Just again, thank you all for joining us, and I look forward to next month. And again, thanks, Dan, for joining us as our special guest.
Thank you for having me. It was an honor to share this virtual stage with so many great insights and minds. You're all so great.
Yeah, we appreciate you taking all our space questions.
Have a great Monday, everybody.
Thank you.
Awesome.
Bye-bye.
Thanks all. Bye.